Hey everyone, hopefully you enjoyed the video on physical and chemical properties. Now we're going to discuss some physical and chemical changes. So we're actually going to alter what's going on with the compounds that we're looking at. Let's first talk about physical changes. So imagine a hypothetical situation. You're at home, minding your own business, maybe watching some sweet chemistry videos. You're working on your note guide, it's on paper, and all of a sudden, classic example, your dog eats your homework. What the heck is going on here? Well, if we look at it from a physical and chemical change standpoint, when your dog ate the homework, maybe your dog did a little bit of tearing to the paper. That is a physical change because we didn't change the chemical makeup of the actual paper itself. All we did is we tore that paper in half. Yeah, it's nasty, there are bite marks, there's saliva, what have you, but we didn't really change the chemistry of the paper. Same thing if we crunch that thing up into a little ball. We haven't changed its actual chemical composition. The one that people always get hung up on is changes in state. So this doesn't mean that we're leaving Pennsylvania. Different kind of state change. We are going from solid to liquid to gas or vice versa. So let's imagine that we have water. Water in its solid form we call ice. It has a chemical formula. It is H2O. Water in its liquid form we call water. It has a chemical formula. It is H2O. Water in its gaseous form, that also has a chemical formula. No surprise here, it is H2O. So the fact that we are dealing with H2O in every single one of those states means that we have not changed the actual chemical composition or the chemical formula of the compound, which means changes in state, whether we're going from solid to liquid to gas or vice versa, those are actually physical changes. Conversely, chemical changes are things that actually do change the chemical makeup of whatever we're talking about. So for instance, if we burn something, oftentimes when we burn something, or always when we burn something, we change the actual chemical formula of whatever we're burning. So we used an example before where we burned propane, and propane was C3H8. And when you burn this propane, that's what's in your gas grill if you have one of those, you combine it with oxygen in the air and you make carbon dioxide and you make water. And so you have made something completely different. You'll notice that the chemical formulas over here on the left-hand side, on the reactant side, are totally different than the chemical formulas on the product side here on the right. And so that means that we have a chemical change because we have changed the chemical formula. Same deal if we do something like burn wood, we are releasing a lot of that carbon that was contained in that wood back into the atmosphere as carbon dioxide, so we're changing the chemical formula. When it's wood, it's probably a compound called cellulose that plants make when they store carbon. So here's a simple way of deciding whether we're dealing with a physical or a chemical change. And the big deal, or the big idea, is really, have we changed the actual chemical composition? Has the formula changed? So for instance, if we're again dealing with water, if we take water and we freeze it, water that is liquid has a formula of H2O. If we turn that into water that is solid and it's still H2O, you'll notice that we have not changed the chemical formula. However, if we do a reaction with water where we decompose that water into, let's say, hydrogen and oxygen, we've changed the chemical formula, and so that would be an example of a chemical change. Now would be a really good time to pause the video if you'd like, so that you can get some practice, and then once you've had some practice, we'll go through and we'll talk about these different examples and see how you did. So hopefully you had a chance to pause the video and try these different practice problems. Let's talk about whether these are all physical or chemical changes. So iron being melted, keyword here melted. Melting is a change of state or a phase change. Iron is the symbol Fe on the periodic table. This is iron as a metal, so it's a solid. If we turn that into iron as a liquid when we melt it, you'll notice that it's still Fe. We have not changed the formula. Therefore, this is a physical change. Let's talk about iron combining with oxygen. If iron combines with oxygen, we have that same iron and we react it with oxygen, and we won't worry about balancing, but this forms something called Fe2O3 or ferric oxide, which is also known as rust. And so you'll notice that we've changed the chemical composition of that iron, so that means this is a chemical change. Wood burning in air, if it burns, anytime we're burning, we are changing chemical composition. So when we burn, this is a chemical change. Rock being broken into small pieces. If you have a big rock, like so, It's a beautiful rock, I know, and you split it into a whole bunch of little, that looks like a figure 8, but don't mind me. We're just making little small rocks. Those rocks still have the same chemical formula, so this is a physical change. Milk turning sour. Well, when milk turns sour, that is a reaction going on. There's probably likely some fermentation happening. So if it is fermenting or doing something crazy with food, whether we're cooking it or it's going bad or spoiling, we have a different chemical formula at the end of the day. So this is a chemical change. And finally, if we talk about wax melting and then catching fire and burning, you hopefully saw the trick question going on here. The step of melting, this part, is actually a physical change of state, but the part where we actually burn, this is a chemical change. So trick question,